Hi, this is Dr. Simon Romero. I'm here to present you the video tutorial for tangent planes to graphs of functions of two variables. So we're going to start noticing that these two vectors that we have right here, we have seen that these two vectors are actually tangent to the graph of the function of two variables at the point AB, f of AB. Now, in order to find an equation for a plane, we need a vector that is normal to the plane. In other words, a vector that is orthogonal to these two vectors in particular. So how do we do that? Well, we just take the cross product. Taking the cross product, we obtain this vector right here. The order, it doesn't really matter, but I put it like this just to have a nice, some positive signs here. Now the point in the tangent plane, well, is the point of tangency. That is the point that I have right here. And finally, well, we can compute the equation by putting the normal vector outside of the parentheses, and inside of the parentheses putting AB and f of AB, that is the coordinate of the point in the plane. Notice that the only variables that we're going to have here is x, y, and z, and those variables are going to, if they appear, they are going to appear with a power of 1. That will give us a plane. So here is the formula. One particular expression of this equation that is going to be useful is when you solve for z. But when you solve for z, the thing that you obtain is this equation that we have right here. Again, notice that the function is evaluated as well as the partial derivatives. So that means that all these guys are going to be numbers as well as a and b over there. So the only variables that are going to appear here are, if they appear, are going to be c, x, and y. Let me give you an example. Find the equation of the tangent plane to the surface c equal to 4x over y at the point given in here. So this surface is actually the graph of a function of two variables. Why? Because the c is solved, and the function is 4x over y. Note also that when you evaluate f of minus 1, f of the x, and the y that is given, the thing that you obtain is the value of the function. So we need to evaluate the partial derivatives at the particular a and b, or at the particular x and y inputs. In this case is minus 1 and 4. So we first compute the partial derivatives, and then we evaluate at minus 1, 4. And notice that after evaluating, we're going to end up with numbers, and those numbers are going to be the coefficients of the x and the y. Inside of the parentheses, we're going to put the coordinates, the x and y coordinates of the points of tangency with a minus, and notice that this is the value of the function that I am just putting right here. Thank you.